Okay, so let's move on. Let's talk a bit about attention, change blindness, and related topics. So, um, so first we'll talk a bit about change blindness, like I said, which is of course the experiment you just did. Then we'll talk a bit about some other visual attention tasks and eye tracking and how they all connect. When it comes to attention, there's kind of a lot of different techniques and measures. Some of them are behavioral, some of them are involve eye tracking. Well, I mean, that's technically still behavioral, but there's kind of pros and cons to each approach as we're going to see. So starting off though, change blindness is of course the experiment you just did. What I normally do eye tracking for this chapter, but that's not really possible. So change blindness. This is the finding that it is surprisingly hard to spot changes between scenes, as you just experienced. So you show people a couple of scenes, right? There's a brief interruption, like a blank screen in between. We'll get to the significance of that. And there's some sort of change. So for example, in this one, like the people disappear. I can't tell if the picture's just cut off or not. But the people disappear. The branch disappears. Also, this this building over here also disappears. And people find it remarkably hard to spot those kinds of changes, stuff you would assume would be obvious. So take a second and think about why this might be. Why is it so hard to spot changes in our environment? Well, just like with memory, we don't actually take in as much as we might think. We tend to remember kind of the overall meaning, the important parts of a scene, right? Don't necessarily remember all the details, especially in a complex scene, right? So in this one, there's quite a few different things to look at. We're not able to attend to them all at the same time, right? We can only really fixate on one at a time. And when this change is fairly subtle, it becomes quite hard to see. But kind of building on that idea, think of it this way. If I asked you, are you aware of this outlet behind me? Well, you would of course say yes, right? But were you actually aware of it before I brought it to your attention? Probably not, right? The reason for that is that your attention can shift so quickly and it does it so frequently that it gives the impression like we're basically taking in everything, right? So if I tell you, are you aware of this? You weren't aware of it, but me asking you about it, your attention shifts to it so quickly, your gaze can switch to it so quickly that it gives you the impression like you were seeing it the whole time, right? So if I said, again, are you aware of this outlet? You're actually not aware of it until I ask you about it. Then you shift your attention to it. But again, you do it so quickly and so easily that you get the impression internally like you were aware of it the whole time. And change blindness kind of illustrates how that is an illusion, right? So in the same kind of example or similar example, if I point out to you, are you aware of this branch? You of course become aware of it then, but when I don't tell you what to focus on, then it becomes difficult to really take in everything, right? So just as a side note, probably a lot of you took the strategy of, this is what most people tend to do with change blindness, is focusing on one object at a time. So you might fixate on this globe here and look at it from picture to picture. Okay, that didn't change. How about, the water, did that change? this building, did that change? And you kind of keep fixating on objects until you find the one that changes or the several that change, right? But again, in reality, you can only focus on, to some degree, one thing or one area at once. So all that other stuff, you kind of remember the overall. So if you're fixated on this globe, you kind of have a general sense of what's in the background, maybe the water, the sky, some grass, but you're not really fully aware of those things until you focus on them directly. And that's probably why you have to go one object at a time to see what changes. So like I said, seeing everything is kind of an illusion. It's not the case that we are aware of everything in our visual field, but our attention can shift so quickly, it gives us the impression that we are seeing everything. In reality, we only kind of take in and remember or are aware of the most important features of a scene. So kind of a question building off of that, do our visual systems suck? It kind of seems like, well, if we can't notice such obvious changes, maybe our visual systems are not that good. Well, not exactly, because I think our visual systems are pretty remarkable in a lot of ways. It's only in these experiments, same with our memory, really all of our cognitive functions are quite remarkable. But with that said, there are certain experiments you can do to kind of expose weaknesses, right? There's certain things, there's certain strategies and kind of ways of compensating we have for our different cognitive abilities that, make it seem like everything is fine. And usually 99% of the time it is. But these particular experiments are kind of meant to expose those infrequent times where, kind of relying on those heuristics or strategies or ways of compensating can fail us. Okay, another question to think about. Why do you think we use a flicker? So if you remember in the experiment, right, it's not that you don't go instantly from one picture to another picture. In between, there's like I think it was about a half second, actually. You could have changed that if you wanted to. Bottom line is a very quick blank screen between the two pictures. Why do you think that is? Well, this is what I mean when I say our visual systems can compensate for things in a lot of neat ways. So when you don't have a flicker, change blindness basically goes away. So if you were to go, it doesn't have to be a flicker, but you need some sort of disruption between the first scene and the second scene. When you go instantly from one to the other, you get almost no change blindness. The reason for that is that one way our visual systems can compensate for not being able to focus on everything at one time is movement can easily attract our attention. Movement is a very strong predictor of where our attention will go. So basically, you're taking in a lot of this stuff, but it's also fading very quickly. But when something appears suddenly, and you don't get that break, that's going to grab your attention. So this, it kind of almost goes back to the idea of sensory memory, although there are some issues with that theory that if you remember any of that stuff, that you're taking in all this stuff to some degree, but it fades extremely quickly. But when there's movement involved, that kind of allows you to shift your attention to the change. When there's a flicker in the middle, you don't really know where to focus. It kind of intervenes and kind of supersedes any movement that might attract your attention. So this, because the branch is appearing, that is a form of movement. And again, if there was no flicker there, that would instantly grab your attention. But with the flicker in the middle, you kind of basically your whole visual system is almost scrambled and you don't know where to attend. When it appears instantly, it will actually grab your attention. So that's why we use a flicker. But like I said, it doesn't have to be a flicker. There's other techniques you can use, something called the mud splash, where like a bunch of the screen will be almost not covered with actual mud, but it kind of looks like a mud splash. Usually just, even if you have two pictures next to each other, there probably needs to be a little bit of separation. Just moving your eyes from one to another, that kind of disruption is enough to kind of mask the appearance or the disappearance of an object. The bottom line is there does have to be some sort of disruption, some sort of, whether it's an eye movement or a blank screen or a mud splash, there has to be something in between the first image and the second image. Otherwise, kind of the motion involved in the change will grab your attention. You can spot it fairly easily, right? So kind of relating this back to the general idea of how our visual system can compensate for various things. You can imagine how that would be at play in a real life scenario. So let's say, you were just looking at a scene, say you were looking at an empty room in front of you, right? And someone suddenly jumped into your field of vision. Well, that would grab your attention, right? Just like a branch suddenly appearing would grab your attention, right? With no disruption. So if you're staring at it and you're not, there's no interruption, nothing in between, it's hard for change blindness to occur because, again, our visual systems are smart enough to use that sudden appearance, that kind of movement involved, to grab our attention. And that's why we don't often see change blindness, or it doesn't seem like we would show change blindness. But on the other hand, if you were to say look down and something were to change in a scene you were looking at before you look back up, you would probably not notice it. Okay, but with this whole idea of how our visual systems can compensate and kind of account for, have ways around this issue of why we can't, see everything and attend to everything at once, you can imagine where this would create some kind of pretty powerful illusions to people, right? And this is where we get into the idea of change blindness. Blindness, that's not a typo. So Levine et al., 2000, did the following. They showed people kind of a typical change of blindness, like a single trial. So meaning you show one instance of where there's a picture and then there's a different picture and something has changed, but they actually point out the change to them, right? So it'd be like, if I showed you this picture and I said this branch is going to disappear, and then I showed you the next picture. So you give them the answer. And then they ask people, would you have noticed that change? I think there's a couple variations. Sometimes they ask, would you have noticed it, or what percentage of people do you think would have noticed it? And 83% said that they would have noticed that change. So once you tell people, oh, the branch is going to disappear, they think, yeah, I definitely would have noticed that. Right? In reality, when you actually compare it to just on a single instance of one picture to another, only 11% actually notice it. So there's this kind of, you can, again, going back to the idea of how our visual systems are really good at compensating for this, I guess you could call them problems. Again, that gives the illusion like we see everything. And that's why once something is pointed out to you, like I said, with the outlet, it seems so obvious. It seems like, yeah, I was definitely aware of that. But in reality, when it's not pointed out to you, only very few people are aware of it. So that's why you get this huge overestimation of, how many people they think, or how likely they were to notice it, when in reality, so few people actually notice it. So people have built on the idea of change blindness in quite a few different ways. They've looked at it in different modalities, meaning does it work with your other senses? So there is something called change deafness as well. Spent it all in 2011. We were doing did a phone interview with people, and at some point during the interview, they switched out the person on the call, not the person who was listening that they called up, but the person giving the interview. They switched them out for someone else, and very few people noticed. So it's not just vision; it seems to work with sound too. There's, I think, some articles on smell as well. You could look at that if you want to on your own. One thing though to keep in mind with these studies is there might be kind of some expectations coming into play here. So it might be the case, I wouldn't be surprised at least with this one, not so much with the vision ones where you're actually telling them to look for a change, but in a situation like this where, you know, who would possibly expect that there's going to be a change like this, that suddenly you're going to be talking to a new person, and that almost that kind of expectation of what's going to happen and what would be normal kind of influences them to be, you know, less suspicious or less aware. That's my opinion. I could be wrong though. Okay. Now, you've probably seen this before, but it's definitely worth watching it again. Do you think, so although change blindness does seem to happen and depend a lot on where you fixate, so what you're looking at, what you're focusing on, and how we can't take everything, that's not always the case. In fact, you can still get robust change blindness when looking at insignificant objects. So I'll stop the video here. Watch the next video in the playlist. Again, you've probably seen it before, but you'll see what I mean.